Have you ever stopped to wonder what goes on beneath your feet? In this video, we delve into the secret world of ants, uncovering their complex societies, mind-boggling communication, and remarkable abilities. Get ready to be amazed by these tiny titans of the natural world. Start with a captivating visual. Macro shots of ants going about their daily routines,
highlighting their intricate details and movements.
Briefly explain the importance of ants to our ecosystems, setting the stage for exploring their significant role in nature. Their world is invisible to us, yet it operates with clockwork precision. These creatures have existed for over 100 million years, evolving into societies more advanced than we imagine. As we go about our day, ants are tunneling beneath the ground, defending their colonies, harvesting food, and raising their young all in harmony. This tiny world thrives without our attention. But what if we could step into it for just a moment? Through their behavior, structure, and impact, ants offer a masterclass in organization and survival. They outnumber humans 1,000,000 to 1, and their influence stretches from the forest of the Amazon to the cracks in your sidewalk. Each ant plays a role, and each colony functions like a superorganism. These superorganisms are responsible for processes we rely on, like soil health, pest control, and even seed dispersal. Their architecture, communication, and social order are more intricate than some modern cities. From the moment an ant hatches, its life is dedicated to the colony. There is no ego-only function. Today, we're diving deep into this microverse. Because when we understand ants, we understand something far greater: nature's blueprint. Explore the hierarchy within ant colonies, highlighting the queen ant's crucial role in reproduction and colony expansion. Illustrate the intricate communication system ants use, focusing on chemical signals and their role in coordinating colony activities. Every ant belongs to a caste. Queens are the matriarchs, tasked with reproduction. In some species, they can live for decades, producing millions of offspring. Workers, the most numerous, do everything from nursing larvae to building tunnels, defending territory, and foraging for food. Despite the lack of eyes or ears in many ants, they communicate through a complex chemical language. Pheromones guide their actions, telling them where to find food, when to attack, or how to protect the queen. Even if thousands are wiped out, the colony adjusts and continues functioning seamlessly. Some ants have evolved to become parasites in other colonies, exploiting the very social structure they once followed. Others adapt roles depending on need. Builders today, foragers tomorrow. Their flexibility is their strength. This organized chaos is what lets ants thrive in deserts, rainforests, and even cities. Their social unity is not only their secret to survival, it is a model of balance few other species, including humans, have achieved. Segment 3. Ingenious engineers and architects show how ants are highly skilled engineers and architects, building complex and elaborate nests. Focus on the different types of ant nests, including underground chambers, mounds, and arboreal nests, showcasing their adaptability. Highlight the engineering marvels of ant nests, such as their ventilation systems, intricate tunnels, and defense mechanisms. Ants build with purpose, not just instinct. Some nests are so vast, they span football fields underground, with rooms for every colony task. Leafcutter ants have dedicated trash chambers to isolate waste and bacteria, an example of primitive public health systems. In the treetops, weaver ants craft leaf nests using silk from their larvae. One group holds leaves in place, another sews them shut, teamwork at its finest. Some ants create tall soil mounds with internal climate control, ensuring heat is expelled during the day and retained at night. Their ventilation systems often resemble those used in modern skyscrapers built to maintain airflow and temperature. Army ants, which never build permanent homes, link their bodies to form living nests or bivouac safe, flexible shelters that move with the colony. In flood-prone areas, ants build rafts using their own bodies, protecting the queen and larvae from drowning. Researchers who filled abandoned nests with molten aluminum revealed structures with spirals, shafts, and chambers, proof of their architectural genius. They don't need tools or blueprints. They need coordination, repetition, and generations of evolutionary learning. From sandy deserts to humid jungles, ants mold their environment with intention and intelligence. In the grand design of nature, ants are more than survivors. They're builders of civilizations. Unraveling the secrets of ant navigation, explore the fascinating world of ant navigation, highlighting their ability to navigate vast distances using various cues. Discuss how ants utilize pheromone trails, celestial navigation, landmark recognition to find their way back to their nests. Show real-world examples of ant navigation such as foraging expeditions, colony migrations, and their incredible ability to find food sources. An ant may travel hundreds of body lengths to find food, but it never loses its way. How it remembers. Desert ants use the position of the sun and count steps with remarkable accuracy to find their way back, even across scorching, featureless terrain. Others memorize visual landmarks like rocks, tree bark patterns, or light angles to map their surroundings. In crowded environments, ants follow pheromone trails that grow stronger with each returning forager, creating chemical highways to food. If the trail breaks, ants quickly adapt, testing new routes, laying fresh paths, and updating their navigation map. Some species even use polarized light from the sky to orient themselves, something human eyes can't do. Scientists have found that ants can teach others through tandem running. A mentor ant walks slowly, guiding a follower to a location. Ants are so efficient that robotic engineers are now mimicking their navigation methods in autonomous machines. Colony migrations are another marvel. Thousands of ants moving in perfect coordination to a new home miles away. Navigation isn't just instinct. It's a mix of memory, communication, and adaptability qualities we often associate with higher intelligence. In the labyrinths of forests and cities alike, ants find their way not just with precision, but with purpose. Their navigation is a daily miracle unseen, unspoken, and yet masterfully executed. Ants, guardians of the ecosystem, emphasize the crucial role ants play in maintaining healthy ecosystems, acting as natural pest controllers and decomposers. Explain how ants contribute to soil aeration and seed dispersal, highlighting their importance to plant growth and biodiversity. Conclude with a call to action. Encourage viewers to appreciate the vital role of ants in our world and protect their habitats. Ants are nature's unpaid workers, maintaining balance across ecosystems without asking for credit. As predators, they keep pest populations like termites, caterpillars, and aphids in check, reducing damage to crops and forests. Their foraging and tunneling help loosen soil, allowing roots to breathe and water to flow deeper into the earth. By carrying seeds and dropping them along trails, ants help grow new plant life, sometimes forming entire meadows. In tropical rainforests, some plants rely entirely on ants for protection, food, and seed, spread true ecological partnerships. When organic matter decays, ants consume and recycle it, preventing buildup and disease in the environment. Their presence is often an indicator of healthy ecosystems where ants thrive and biodiversity follows. But human activity like deforestation and pesticide uses pushing many ant species to the brink. Losing ants would be like pulling the screws from a machine. The entire system could falter. We often overlook them because they're small, but ants are foundational to life as we know it. Let's not take them for granted. Let's protect their habitats, minimize harmful practices, and encourage coexistence. Because the more we learn about ants, the more we understand our place in nature's design. The ant war machine. Not all ants live in peace. Some are born for battle. Ant colonies often clash with rival colonies in brutal wars that involve strategy, sacrifice, and even slavery. Army ants are a prime example. Nomadic predators that travel in columns of thousands, overwhelming everything in their path. Some ants, like Polyergus, are known as slave-making ants. They invade neighboring colonies and kidnap pupae, forcing them into servitude. Fights can last hours, sometimes days, with ants using coordinated ambushes, flanking maneuvers, and sacrificial charges. Their wars are waged over territory, food, and survival, no less intense than the battles we see in the human world. Researchers have observed that some colonies use scouts to assess enemy strength before attacking. When defeated, a colony may surrender its queen or flee and rebuild in secret. In the ant world, power is taken, not given. And once taken, it is defended at all costs. These aren't just bugs, they're warriors, strategists, and conquerors. Ant intelligence. Beyond instinct. How do ants make decisions with no leader, no brain like ours, and no language? The answer lies in what scientists call emergent intelligence. Ants follow simple rules like following the strongest scent trail or avoiding overcrowding. But collectively, those rules create highly adaptive behavior. Ants can solve mazes, calculate shortest paths to food, and even build escape routes during floods. In labs, ants have demonstrated the ability to weigh food sources by assigning more workers to better options. They also exhibit memory. Desert ants remember paths and distances, even in total isolation. Some species have been seen prioritizing tasks, switching roles based on colony need. When food is scarce, colonies reduce egg laying, redirecting energy toward foraging. This adaptability is what makes ants one of evolution's greatest success stories. They're not just acting on reflex, they're responding to change. And that, in itself, is intelligence. Ant communication. A language without words. Imagine running a city with no phones, no writing, no spoken language. Ants do it every day. Their secret lies in chemical communication, using pheromones to transmit messages in real time. One trail can mean food, another danger. Some chemicals even calm or excite colony members. But that's not all. Ants also use touch, body movement, and even vibrations to convey messages. When an ant finds food, it leaves a scent trail. If the source is good, more ants follow and reinforce the trail, creating a positive feedback loop. When under attack, ants release alarm pheromones that rally defenders instantly. In leafcutter colonies, workers emit different signals to separate tasks like cutting, transporting, or cleaning fungus. It's not a spoken language, but it's fast, precise, and incredibly effective. Scientists studying this system are developing robots and AI models based on ant language. Through scent, touch, and rhythm, ants are telling a story. We're just beginning to understand what it means. Super colonies, the global networks of ants. Some ant colonies are so large, so connected, they span entire continents. These are called super colonies, vast, sprawling networks of ants that act as one united entity. The Argentine ant, for example, has formed a super colony stretching across southern Europe and parts of the US, with no infighting between distant nests. This cooperation is unprecedented. Normally, colonies are hostile to outsiders. But in super colonies, ants from different nests recognize each other as kin. Scientists believe this is due to a shared chemical signature, like a passport that grants access across the network. Super colonies dominate resources, outcompete native species, and adapt rapidly to urban environments. Their power lies not in aggression, but in overwhelming unity. Ants within these networks communicate, cooperate, and conquer as a collective. Some researchers warn that these ant networks may become ecological threats in certain regions. But one thing is clear: ants have mastered global cooperation long before we did. Now show some species of ants, of leafcutter ants. The mushroom farmers, deep in the rainforests of South and Central America, unique species of ant practices agriculture. Leafcutter ants don't eat leaves, they cut them and use them to grow fungus, which becomes their true food source. Their colonies can contain millions of workers, organized into castes, cutters, carriers, cleaners, and guards. As lines of ants march through the forest, they form living highways, each ant carrying a piece of leaf much larger than itself. Inside their nests, the leaves are processed and fed to a carefully cultivated fungus. This symbiotic relationship has existed for millions of years, long before humans invented farming. Leafcutters even have waste chambers to discard diseased fungus, protecting the colony's health. Some carry antibacterial secretions to sterilize leaves before processing. It's not just survival, it's a sustainable farming system with sanitation, division of labor, and crop management. These ants are not just foragers, they are true farmers, perhaps the first farmers in Earth's history. Fire ants, the aggressive survivors, native to South America, but now found worldwide. Fire ants are infamous for their painful sting and aggressive behavior. They're opportunists, nesting anywhere from gardens to power boxes, causing damage and discomfort. Their colonies spread quickly, often displacing native ants with sheer aggression and adaptability. Fire ants can sting multiple times, injecting venom that causes burning sensations, hence their name. But they're also survivors. When floods hit, fire ants link together to form floating rafts, protecting their queen and brood. They use their bodies as building blocks, trapping air bubbles between them to stay afloat for weeks. Their nests are built to withstand external damage, and they relocate swiftly when threatened. Fire ants may be small, but their sting, both literal and ecological, is deeply felt. Yet even with their dangers, they're a symbol of resilience and adaptability in the face of constant change. Weaver ants, the aerial architects high in the trees of Africa, Asia, and Australia, live the weaver ants, known for their remarkable leaf nests. These ants pull living leaves together and sew them shut using silk produced by their larvae. The process requires cooperation. Workers hold leaves in place while others carry larvae like glue dispensers. The result is a strong, weather-resistant nest suspended among the branches. Weaver ants are also fearsome defenders, fighting off birds, insects, and even snakes from their tree homes. Farmers in Asia have used them for centuries as natural pest control in fruit orchards. They don't sting, but they bite fiercely and spray formic acid into wounds, highly effective in battle. Their communication is fast and precise, allowing rapid responses to threats or structural damage. They are warriors, architects, and guardians of the treetops, living proof that innovation isn't exclusive to humans. Bullet ants. Nature's painful giants deep in the Amazon jungle lives an ant feared across the insect kingdom. The bullet ant. At up to 1.2 inches long, they are giants of the ant world and deliver the most painful sting known in nature. Despite this, bullet ants are not aggressive unless threatened. They are territorial, but rarely attack without reason. Their colonies are smaller than others, with fewer workers, but they make up for it with power and endurance. Some Amazonian tribes use bullet ants in initiation rituals, where young warriors must endure multiple stings as a test of courage. Bullet ants forage in solitude, using powerful mandibles and chemical scent trails to navigate. Their strength lies not in numbers, but in intimidation. In a world of organized swarms, the bullet ant stands alone. No one dares challenge it. Carpenter ants, army ants, and the final lesson, the carpenter ant. Often mistaken for termites, is a master of woodwork, hollowing out logs and beams to build their homes. Unlike termites, they don't eat wood. They shape it, creating tunnels that form complex, sprawling nests. Carpenter ants are found in forests and homes alike, and they're nocturnal, making them difficult to detect. Then there are army ants, the relentless nomads of the jungle. With no permanent home, they march across the forest floor like a living tide. They hunt in massive swarms, killing anything in their path from spiders to lizards. Army ant raids are military operations, scouts, flanks, and coordinated ambush assault, guided by pheromones. Their mobile colonies form living bivouacs nests made entirely from their bodies. After exploring their world, its clear ants are more than insects. They are mirrors of civilization. Their teamwork, communication, adaptability, and resilience hold lessons for human society. Ant colonies show us how distributed systems can solve problems without central control. They prove that intelligence isn't limited to individual brains. It can emerge from community and cooperation. In ants, we see the power of unity, of discipline, of shared purpose. Their architecture inspires engineers. Their efficiency inspires programmers. Their resilience inspires anyone willing to survive and thrive against the odds. But most of all, they remind us that size doesn't measure significance. Beneath our feet lives a world more complex, more ancient, and more incredible than most people will ever know. The next time you see an ant, pause, watch, learn. Because inside that tiny frame is the story of nature's greatest empire, and perhaps a glimpse of our future. Ants are not just tiny bugs. They are builders, farmers, warriors, survivors. They've existed for over 100 million years, shaping ecosystems before we ever walked the earth. Ant societies are advanced, their behaviors complex, and their survival strategies nearly flawless. What ants lack in size, they make up for in purpose, organization, and sheer will. We walk above them daily, unaware of the empires that thrive below. But now, you've seen the secret life of ants. Thanks for watching. Don't forget to like, subscribe, and share if you want more hidden stories from the ants' natural world.